So we started factoring polynomials completely and finding all of their real zeros. We want to continue doing this in this video. We're going to do some fourth degree polynomials where the largest power is a power 4. So I have the polynomial 4x to the fourth plus 5x cubed minus 7x squared minus 10x minus 2. And I don't know where to start factoring that. So let's see. Maybe I'll just try looking at the possible rational zeros. Let's look at the possible rational zeros. So I'm going to take the divisors of minus 2, the constant, we call that, those divisors are the p's, and the divisors of the q's. The q's are going to be, or rather the q's are going to be the divisors of the leading coefficient 4. So we're going to have, let's see, divisors of negative 2 are plus or minus 1, as well as plus or minus 2. As for the divisors of 4, the leading coefficient, those would be plus or minus 1, plus or minus 2, plus or minus 4. Now we go through all the combinations, top over the bottom. So the blues over the plus or minus 1, the blues over plus or minus 2, the blues over plus or minus 4. So we get plus or minus 1, plus or minus 2, that's over 1. Okay, now let's do them all over plus or minus 2. So plus or minus 1/2. Plus or minus 2 over plus or minus 2 is 1. So we're not going to write that one down again. Okay, now we're going to do them all over plus or minus 4. Plus or minus 1 over plus or minus 4 is plus or minus 1/4. Then we have plus or minus 2 over plus or minus 4. That's plus or minus 1/2. We've already done that. So if we have any rational zeros, if we have any solutions to taking this equation and setting it equal to 0, they're going to come from these, the rational ones. All right, let's try plugging in. Hey, I've already gone through negative 1. So let's plug in negative 1. So since f of, we're going to plug in negative 1 for x here. I already tried this one out. I got it to work with negative 1. Let's plug in negative 1 for x. See what happens. Okay, negative 1 to the fourth power is positive 1 times 4 is 4. Let's see. No, hold that back. Negative 1 cubed is negative 1 times 5 is negative 5. Negative 1 squared times, negative 1 squared is 1 times negative 7 is negative 7. Negative 10 times negative 1 is positive 10. And we have a minus 2. And let's see, 4 minus 5 is negative 1. Negative 1 minus 7 is negative 8. Negative 8 plus 10 is positive 2. Positive 2 minus 2 is 0. So since f of negative 1 is 0, that means then x equals negative 1 is a 0 of the polynomial f of x. In other words, x plus 1 is a factor of the polynomial f of x. So if I write down my polynomial f of x, that means it factors into x plus 1 times something else. We'll figure out what that is. So I have one of my zeros. Okay. So I'm going to take this factor here of x plus 1, and we're going to divide that into our polynomial, which is 4x to the fourth power plus 5x cubed minus 7x squared minus 10x minus 2. And we're going to do this using long division. So x plus 1 is our factor, also called your divisor, and we're dividing that into the polynomial, which is going to be our dividend, and we're going to try to come up with a quotient up top. So first I have to ask the question, okay, what times x, what times is red x out front? I'm going to make it red. times this red x gives me 4x to the 4th power. 4x to the 3rd power. So I'm going to put 4x to the 3rd power up top in the cubing column. That's called the cubing column where the cubes go. The cube column. The cube column. Okay, now I'm going to take this red 4x cubed. I'm going to multiply it by our divisor. Come on now, don't do that. There we go. Come on, don't do that. Okay. 4x cubed times x is 4x to the 4th. 4x cubed times 1 is positive 4x cubed. Okay? And now we're going to subtract the blue 4x to the 4th plus 5x cubed minus the red 4x to the 4th plus 4x cubed. So when we subtract, we get the 4x to the 4th cancel. We get 5x cubed minus 4x cubed is going to give me a single 1x cubed. So I'll just write x cubed. They're going to bring down my minus 7x squared from above. Now I'm going to ask the question, okay, what times that red x out in front gives me this x cubed right here? Well, I say x squared. So I'm going to put a positive x squared up above in the square column. Now I'm going to take that x squared. I'm going to multiply by x. I'm going to get x cubed. I'm going to take that same x squared and multiply it by my green 1. I'm going to get positive x squared. Okay. And I'm going to subtract. What am I going to subtract here? I'm going to take my x cubed minus 7x squared in blue minus my x cubed plus x squared in red. So when I subtract, the x cubes cancel, and I get minus 7x squared minus an x squared gives me a minus 8x squared. Okay, bring down my, from above, 10x, the famous 10x. So now we're going to ask the question, what times that red x out in front can you multiply by to get negative 8x squared? What can you multiply that red x out front by to get negative 8x squared? You say, well, minus 8x. So I'm going to write a minus 8x out. Up top, where the quotient goes. And that's going to be in the x column, the minus 8x. So let's take minus 8x times x and get minus 8x squared. Now let's take minus 8x times 1 and get minus 8x. Okay. Now let's subtract the blue 8x squared minus 10x minus negative 8x squared minus 8x. Okay, so that make negative 8x squareds cancel. And when you take negative 10x minus negative 8x, that's the same thing as taking negative 10x plus 8x. It's going to be minus 2x. Okay, and then I'm going to bring down this minus 2 here on the end. And now I'm going to ask the question, what times that red x out front gives you the minus 2x? The minus 2x right here. Well, you can say minus 2, and minus 2 is going to go in the constant column up top. So I'm going to take minus 2, multiply it by the red x. I'm going to get minus 2x. And also I'm going to take that minus 2 up top and multiply it by 1. I'm going to get negative 2. And then I'm going to subtract the blue minus 2x minus 2 minus the red minus 2x minus 2. And that zeroes out, right? Things cancel. I'm going to put a double line to indicate cancel. So you're not going to have a remainder. You have a remainder of 0, in other words. And that's what you want. Remainder of 0, because that's the way it should be. If it factors, you won't have a remainder. So here we're going to have 4 x cubed plus x squared minus 8x minus 2. Okay, that was our quotient that we just found. So the polynomial factors into x plus 1 along with 4x cubed plus x squared minus 8x minus 2. The question is, how can we factor this red dude, 4x cubed plus x squared minus 8x minus 2? Well, first I'm going to copy down the green, x plus 1. We don't want to lose that. And now the red, I'm going to say, hey, red, look at you. I can do something called factoring by grouping. So I'm going to group these together, the yellows, and these together, the yellows. So I'm going to put a pair of parentheses around, and we're going to have 4x cubed plus x squared together in a pair of parentheses. And I'm going to have a plus pair of parentheses, and then in that second pair of parentheses, I'm going to put the minus 8x minus 2. This is going to work. The factoring by grouping here will work out. So let's copy down the x plus 1. In the big red brackets, let's see, what is in common here between the 4x cubed and the x squared? Well, there's going to be an x squared in common, right? And when we take out that x squared, we're going to be left with, let's see, 4x plus 1. Now in the second yellow parentheses, we have a minus 8x and a minus 2, and in common there's a minus 2 we're going to take out. And that's going to leave us in parentheses with then 4x, if I can write 4x in red, plus 1. Okay, so let's go to our next line. Our polynomial consists of the factor in green, x plus 1, then the big red bracket. Now pay close attention. Notice that if you think about this as a term, and this is a term, they both have a 4x plus 1 in common, so we're going to take a 4x plus 1 out. That's in common. In parentheses, that's going to leave behind in yellow x squared minus 2. So essentially what we have is f of x breaks up into x plus 1 as a factor, 4x plus 1 as a factor. And now we have this x squared minus 2, which is in yellow. So how can we break up the x squared minus 2? Well, one way is to take x squared minus 2, set it equal to 0, and solve for x. So we could add 2 to both sides, get x squared equals 2, and then since this is an even power equation, we have to do plus or minus the square root of 2. So that means x equals root 2 and x equals minus root 2 are real zeros of f of x. And that means, so I'm going to circle that. It's important. That means x minus root 2 and x plus root 2 are factors of f of x. Yeah, so we can break up the yellow x squared minus 2 into x minus root 2 and x plus root 2. So f of x equals green x plus 1. That should be green. Four x plus 1. And the yellow can break up into x minus root 2 or x plus root 2. This is going to be your final factorization in this red box. If you don't like that setting equal to 0 method for x squared minus 2, you could actually do this differently with the difference of squares factorization, in which case you have x squared minus 2 is the same thing as x squared minus root 2 squared. And with the difference of squares, you have x plus root 2, x minus root 2. Or you can change the signs, x minus root 2, x plus root 2. However you want to write it. Okay, so do we have everything we wanted? Okay, so we have our factorization in the red box. It's a complete factorization. We have that x equals negative 1 is a 0. I'm going to emphasize that. Okay. We have x equals root 2, x equals negative root 2 are zeros. Okay, we also forgot this red one, so we need to do the red one. So So we're going to take 4x plus 1. That's one of our factors. Set it equal to 0 and solve for x. So we're going to subtract a 1 from both sides. And we're going to divide by 4. And we're going to get x equals minus 1/4 is a 0 of f of x. Okay, so we want to make sure we write down our zeros of f of x. Okay, that completes the problem. Because that's a little bit more complicated than the others. It's a 4th degree polynomial. And luckily, it had the factoring by grouping in there, and then the difference of squares type thing, which wasn't too difficult. So everything factored out nicely. You had 4 linear factors for this. I want to do one more problem where everything maybe doesn't factor out so nicely. It's a little more tedious, maybe in some ways. So this is a number 5. It's another 4th degree polynomial, x to the 4th plus 3x cubed plus x squared plus 3x minus 2x minus 6. And I wouldn't have a clue how to factor that just by looking at it. So I would start with maybe trying out possible rational zeros. So P over Q so my P's are going to be my divisors of -6, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and my Q's are going to be the divisors of my leading coefficient of 1, which is just plus or minus 1. So those would just be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So I can try plugging those into my function and seeing if I get any of those to be zeros. So let's test here. I've already gone through this. I've already tried, I think, which one works? -3, I think, works. Is that right? Yeah, -3 works. I already tried that one. So let's try -3. So we're going to plug in -3. Since f of blank equals blank to the 4th plus 3 times blank cubed plus blank squared plus 3 times blank minus 2 times blank minus 6. So I'm going to plug in a -3 here. That's the one that should work out. I already went through this myself. And let's do it. -3 to the 4th power is 81. Let's see. -3 to the 3rd power is -27. -27 times 3 is -81. -3 squared is 9. 3 times -3 is -9. We're going to have negatives. Come on, don't go away. -2 times -3 is +6, and then we have a -6. So basically what happens is this cancels, and these cancel, and you end up with a 0. Yeah, that's a really interesting thing there, how that works out. So what we know is that x equals -3 is a 0 of the function, or an x-intercept of the function. So that means x plus 3 is a factor of that polynomial. So I'm going to emphasize that. I'm going to circle that. That's one of the things we have to do. No, not the factors, the zeros. I'm going to circle this 0. That's one of the things we have to do in the problem. Find the 0. So we found one of the zeros. So we have a factor. So what we know then is that the polynomial function has a factor of x plus 3. And that has to break up into something else. X plus 3 times something else. Okay, so I'm going to take my factor here of x plus 3. And I'm going to do some long division. I'm going to take x plus 3 in green and divide that into the entire polynomial, which was, come on, get the color right. X plus 3 is supposed to be green. Okay, the color now. So we're dividing x plus 3 into the entire polynomial, x to the 4th plus 3x cubed plus x squared plus 3x minus 2x minus 6. Okay? So now I'm going to make this x here in front red. I'm going to ask the question, what times that red x will give me x to the 4th? Well, x to the 3rd. So I'm going to put an x to the 3rd up above in the cubing column. So now I'm going to take x cubed, multiply it by that x, and I'm going to get x to the fourth. I'm going to take x cubed and multiply it by 3, and I get 3x cubed. Okay. Now we're going to subtract the blue x to the fourth plus 3x cubed minus the red x to the fourth plus 3x cubed. So what's going to happen? It's going to completely cancel out, and we're going to cancel those out, and then we're going to bring down x squared plus 3x. So now I have to ask the question, what times that red x out front would give you x squared? Well, x, right? X times x would give you x squared. So I'm going to write an x over here. I'm going to go all the way over here. That's a plus x. I have to stay in the right column. So I'm staying in the x column. So we're going to take x times x to get x squared. And then we're going to take x times that 3 there, and we're going to get positive 3x. And then we're going to subtract. And now these are going to cancel completely. And we're going to bring down on the right minus 2x minus 6. Now I ask the question, what times that red x out front would give minus 2x here? Minus 2, so I'm going to put a minus 2 up top, and that has to stay in the constant column. So I'm going to take negative 2 times x to get negative 2x. I'm going to take negative 2 times 3, and I'm going to get negative 6. I'm going to subtract the negative 2x minus 6 in blue minus the negative 2x minus 6 in red, and that completely cancels out, and we have a remainder of 0 there. All right, so that means this factored into x plus 3 times this quotient. This quotient is x, can I get this to right? Yeah. X cubed plus x minus 2. Okay. Goodness gracious. So how do I factor the red is the question, right? The red, how in the heck does the red factor? It's getting tough. So what we're going to do, we're going to call the red g. Not easy to factor the red. So let g of x, that's focusing on right here what I'm underlining in red, x cubed plus x minus 2. So we have to factor this now. This is a cubic that we need to factor. So we're going to go back to our method, the rational roots, looking at the possible rational zeros. So possible rational zeros of this new factor, this new polynomial. Possible rational zeros. So here we have a minus 2 for my p. So the factors of minus 2 are plus or minus 1 and plus or minus 2. And for my q, that's the number out front, plus or minus 1. Those are the only factors. So conclusively, we can say we get plus or minus 1, plus or minus 2 is the only possible rational roots here, possible rational zeros. So I've already tested this out. What did I try here? I tried in 1. 1 works out nicely. So we're going to try 1. So since g of 1, we're going to plug in 1 here. Let's plug in 1 for x. 1, that's going to be, let's see, 1 cubed is 1, plus 1, minus 2. This equals 0. So since g of 1 is 0, then that means x equals 1 is a 0 of g of x. Let's make it another color. Let's make it blue. Blue, since we've already used the green 0 earlier. guess it's okay. So what does that mean? That means g of x, or another way to say this is x equals 1 is x minus 1, I should say. X minus 1 is a factor of g of x. Okay. Let's circle this 0 here because we have to find all the zeros, all the real zeros. So we already found a real 0 of -3. Now we have a real 0 of 1. So x minus 1 is a factor of g of x. So now we're going to do some long division. We know that g of x is going to factor into x minus 1 times something else. What color? Yellow. We have to figure out what goes in yellow. So I'm going to do a long division here. I'm going to take x minus 1 and divide that into the g of x function. What was the g of x function? It's the red one, x cubed plus x minus 2. Now notice that I skipped the square column. I skipped the square column here. If you don't like the fact that I skipped it, you can put a 0x squared there, like that, and then a plus. So you want to make sure you leave space for any skipped columns. So even though the square term doesn't show up in x cubed plus x minus 2, you still need to either leave space or make a 0x squared in its place. Okay, so what are we going to do here? First, we want to ask the question, what times this? Let's make it a yellow x here. What times this yellow x would give me x cubed? Well, x squared. So I'm going to put an x squared up top, and that's going to be in the square column. So x squared times x is going to give me x cubed, and then x squared times minus 1 is going to give me minus x squared. And I'm going to subtract the red x cubed plus 0x squared minus x cubed minus x squared. So the x cubes will cancel. And when you take 0x squared minus a negative x squared, you're going to get a positive x squared. And then I bring down the plus x here. Okay. And now I ask the question, what times that yellow x out front would give me this x squared down here? Well, x. So I'm going to write a plus x up top in the x column. And now I'm going to take that x, I'm going to multiply by that yellow x out front. I'm going to get x squared. I'm going to take that yellow x up top and multiply by the negative 1 out front. I'm going to get a minus x. And now I'm going to subtract these. X squared minus x squared is 0. And when I take the red x minus the yellow negative x, it's going to give me a positive 2x. So I have 2x. And then I bring down my negative 2 here. And then I ask the question, what times this yellow x out front will give me this 2x down here? Well, a 2. So I'm going to write a plus 2 up top where the constant column is. So I'm going to take 2 times x is 2x. I'm going to take 2 times negative 1 is negative 2. And I'm going to subtract these, and things will just cancel out, and you get a 0 there. So you get a remainder of 0, which is what you want. That means that when I divided x minus 1 into g of x, which was x cubed plus x minus 2, my quotient here, if I can get this to right, yeah, my quotient here is going to be in yellow, x squared plus x plus 2. So that's what g of x is. So f of x, remember, f of x is equal to x plus 3 times g of x, which we know g of x is x minus 1 times this yellow. Okay, so one more thing we have to do. We have to try to factor this yellow right here I'm underlining in black. Does that factor? Well, you can try to factor it. It turns out it doesn't factor, and the way to actually verify, you really need to verify it doesn't factor. You basically set it equals 0, x squared plus x plus 2 equals 0, and you want to try to solve this. So to solve this, you use a quadratic formula, x equals minus 1 plus or minus the square root of 1 squared minus 4 times 1 times 2 all over 2 times 1. And when you go through the motions here, you get minus 1 plus or minus 1 minus 8 over 2, or negative 1 plus or minus the square root of negative 7 over 2. And notice that this is not real. Not real. So it's a 0, but it's not a real 0. So because it's not a real 0, is not a real 0. It's a 0, but not a real 0. A real 0 is a 0 that's a real number. This is called an imaginary number when you take the square root of a negative number. It's not a real 0. That means, thus, x squared plus x plus 2 does not factor. So since it doesn't factor, then we just leave it. And that means our final answer here is this. F of x factors as x plus 3 times x minus 1 times x squared plus x minus 2. So that yellow portion does not factor in the real number system. You'd have to go into imaginary numbers, and this is something we do not do. We do not go into imaginary numbers here. So you only have 2 zeros. You have 1 as a 0, and you have negative 3 as a 0. And then you have this factorization. There are only 3 factors here. So you have 2 linear factors, and 1 quadratic factor for this one. All right, so we're going to stop there. This will be